The first part of this video is going to go over how to determine equations from graphs. So we are going to write these equations in factored form. So the first thing that we're going to do is identify the x-intercepts. So here we've got -5, we've got -1, and then we've got +2. So that is going to let us write the zeros for all of our functions. So I'm going to do a on the left-hand side here. I'm going to say f at x is going to be equal to x plus 5, x plus 1, and x minus 2. Now, we are looking at a specific function that passes through a particular value. And if you remember from learning about parabolas, we use an a value in front. So functions that have those three zeros or those three x-intercepts represent a family of functions that can be changed by either stretching or compressing relative to the base function. So since we know that our function has the y-intercept, 0, 6, we're going to put in 0 for x and 6 for y, and we're going to solve for that a value to find the specific equation. So I've got 6, I'm going to leave a on its own, and then I've got 0 for x. So I'll just write that in since I'm substituting, but our algebra is going to be pretty straightforward on the next step with that 0. On the left side, I've got 6. On the right hand, I've got a times 5 times 1 times -2. So that is -10. So that means that my a value is going to be 6 over -10, which as a fraction, I can reduce to -3/5. And then I can write my specific equation as -3/5 times x plus 5 times x plus 1 times x minus 2. So let's do this a second time for a second example. So again, first thing I'm going to do is identify my x-intercepts. I've got one at -3, and I've got one at 2. I notice that the function behaves differently than example A around the x-axis. Because this touches at -3 and does not cross, this means that the root has a multiplicity of 2. So when I go to write that in my equation, I'm going to have x plus 3, which is how I know where my 0 is, but it's going to be squared because right around that point, my function behaves like a parabola. The second x-intercept here, it goes through the x-axis, but looks more like a bit of a squiggle. So this one would have multiplicity 3. So that means that I'm going to close my keynote, apparently. That means that we're going to start here with the same kind of bracket. We've got x minus 2. That's how we know the location of our x-intercept. But it goes through the x-axis, and we're going to represent that with multiplicity 3. We still have our a value that's right here, and to identify our specific equation of the following polynomial function, we're going to use our y-intercept to solve for that specific a value. So I'm going to put in -4 on the left-hand side, leave a by itself, and then put in 0 for x. A little bit more algebra involved in here because we have the non-linear x-intercepts. On the left side, we still have -4. On the right-hand side, we have 9 and -8. So we've got -4 is equal to -72. We can write that as 4 over 72, and then we can reduce that to lowest terms. by dividing both of those by 4, and then we can simplify that to 1 over 18, which then lets us write our specific equation here. So 1 over 18, x plus 3 squared, and x minus 2 cubed. And now we found specific equations for the parabolas from graphs. Our other skill that we're going to practice is using long division. So when we're faced with a simplification problem like this, we can actually simplify this by just taking x squared out of all 3 of those terms. So I can rewrite this. If I'm just dividing it out, I can divide it out. I would say 6x cubed plus 3x plus 2. And I would probably have a restriction that x can't equal 0. This works well because we have a monomial that we're trying to take out. But what happens when we have a binomial that we're trying to take out? Well, in this case, we have to remember our long division. So if I had 107 divided by 4, I would look at 4 going into 10. I would say, okay, that goes in twice. 2 times 4 is 8. I would subtract those. I'd bring that down and I get 7. And then I'd say, okay, 4 goes into 27 6 times. And I'd say 4 times 26 is 24. And I would subtract those and I would get a remainder of 3. This lets me write my division statement as follows. I can summarize my division statement as a multiplication and addition statement. So in general, our division statement, d at x, is going to represent little d at x, this is our divisor, multiplied by our answer, our quotient, which is a fancy math word. And then we're going to add on our r at x, which is our remainder function. So we've got time to do in the video one example of this using numbers and letters instead of just numbers. So when we're dividing, we're going to set up our long division bracket the exact same way. I'm going to put my terms from my question underneath the brackets here. This is my dividend. And then in front, I'm going to put my divisor. So now when I go to put the next term up, I'm just going to look at the first term divided by the first term in my binomial. So 3x cubed divided by x. I know that's going to leave me with 3x squared. Now I'm going to multiply back through just like I did before to give me my next line here. So 3x squared times x gives me 3x cubed. 3x squared times minus 3 gives me minus 9x squared. And then I'm going to subtract. The first 2 terms should always cancel out as long as you've done your division correctly. The second 2 terms, if I'm subtracting a negative, I'm actually going to end up adding. So I've got 4x squared. And then I'm going to bring down my next term. Now I'm going to repeat my process. 4x squared divided by x. That is going to give me 4x. And then I'm going to multiply back through again. So 4x times x, which is 4x squared. 4x minus 3 is minus 12x. And then I'm going to subtract again. My first 2 terms cancel out. Second 2 terms, I'm subtracting, which means I'm actually adding, and I'm going to end up with 5x. I'm going to bring down my next term, and then I'm going to repeat the process one last time. 5x divided by x is 5. Multiply back through. 5 times x is 5x. 5 times minus 3 is minus 15. My first 2 terms cancel out. I'm going to end up adding at the end. And then I'm going to say that my division statement is going to be my divisor times my quotient, my answer, plus my remainder.